Now we are clear about the prerequisites for learning NSX Lite. Now let's move into the basics of networking. So we are going to start with the basics of networking from a physical network perspective. So we'll first understand how networking works in the real world with the physical switches, routers, VLAN, routing, and traffic flow. This is important because NSX is built on top of these fundamentals. So once the physical network concepts are clear, then we slowly move to the software defined networking. So first let's try to understand the physical networking concept and then we'll move on to software defined networking. Now before we jump into NSX, let's first understand how networking was done earlier. That is before software defined networking came into picture. Look at this diagram. This is a traditional data center network, something which most companies were using between 2008 and 2013. On the right side, you can see office or branch location. That office connects to the data center using an MPLS cloud. So whenever users from office want to access applications, all traffic travels through MPLS and reaches the data center. Now, inside the data center, everything is hardware based. At the top, we have physical routers. These routers are connected to the MPLS cloud and handle all WAN routing. Below that, we have core switches. Core switches are responsible for high-speed layer 3 routing inside the data center. Then we have access switches. These access switches connect directly to the servers and handle VLAN and layer 2 traffic. If you notice, for every function, there is a separate physical device. Routing is done by routers, switching by switches, firewall by firewall appliances. Now coming to the servers, all applications like DMZ, SQL business application, tools, and security servers are running on VMware ESXi clusters. But servers are virtual. Network is still fully physical. If I want to create a new application network, and in that scenario, what we need to do? First, we need to create a VLAN and access switch, then allow it on core switch, then update routing on router, then configure firewall rules. Everything depends on network team. Now suppose tomorrow your application team says we need one more network for testing. Immediately you have to raise a change request. Network team has to log into the multiple device, configure VLAN, trunk, routing, firewall, and then only application team can start. This is the biggest problem with traditional networking. Another issue is about scalability. If traffic increases, you cannot just click a button. You need to buy new hardware, add cables, then configure it manually, and also troubleshooting also difficult. If traffic is not working, then you have to check router, then core switch, access switch, then firewall. So finding where exactly the problem is takes a lot of time, and security is also the biggest concern. Firewall is usually placed at the edge of the data center. Okay, inside the data center, most servers can talk to each other freely once they are on the same VLAN. That means east-west traffic is not properly secured. No firewall can be implemented on the east-west traffic. So to summarize, traditional networking works, but it is slow, hardware dependent, difficult to scale, and tightly coupled with physical devices. And this is exactly why NSX technologies came into picture. So in the section, I'll show you how NSX removes this hardware dependency and brings networking closer to the virtual machines. That's what we are going to explore in our training. Now we already know how the three-tier architecture works, right? Earlier data centers were built using this three layers: access, aggregation, and core. This works fine when networks were small and applications were simple. But over time, what happened? data centers grew, virtual machines increased, and the servers started talking to others more than the users. Because of this, the three-tier design became slow and difficult to scale. If you want to add more servers or increase bandwidth, you have to make changes at multiple layers, right? You have to think about access layer, aggregation layer, and core layer. So the industry decided to simplify the design. That's what the two-tier spine leaf architecture came. So in this design, servers connect to leaf switches connect to spine switches. Every leaf connects to every spine. This gives faster communication, predictable performance, easy scaling. Then if you need more servers, then you need to add a leaf switch. And if you need more bandwidth, in that case, you need to add a spine switch. That's it. The design works very well with this modern applications and virtualization. And it is the best architecture, sorry, not the best, the base architecture used for software defined networking and NSX. So before we move to NSX, it's important to understand this shift from three-tier to spine leaf architecture. Now look at this slide. Here on the left side, you see the old data center design, right? Which is the traditional three-tier architecture, which we discussed one slide back, right? So here networking is built on layers. As we know, like it's on access, aggregation, and core. And in the right hand side, you can see the two-tier spine leaf architecture, which is that modern architecture which is used in most of the data center. Okay, so before we move into NSX, okay, understanding this comparison is very important. Okay, so now let's move on and take an real-time example for this two-tier spine leaf architecture with connecting and server to leaf and spine switch with some VLAN ID details related to virtual environment. Let's try to understand that. Now, this slide, like we are going to discuss based on a real-time example. Okay, this is how two-tier spine leaf architecture is actually implemented in the customer environments. Okay, here in this diagram on the top, you can see two spine switches. Okay, these spine switches are responsible only for high-speed layer 3 forwarding. Below that, you see so below that you can see that this is connected to a leaf switch. From the leaf switch, it is connected to a server VXL node. Okay, so here you can find the VLAN IDs which is used in the production support like internal management, vSAN, vMotion, guest VM. This is how typically an physical network look like today. Okay, because this is the latest architecture diagram which I took from VXL. Okay, so now this is physical. Okay, so when we are going to implement NSX on this physical, how we are going to implement, that's what we are going to discuss in our NSX class. So before that, we'll proceed with the traditional network architecture and then we'll continue from there.